The silence began not as a failure, but as a feeling, a hollowing in the rhythm of the cosmos. Deep beyond the orbit of Mars, where the sunlight weakens and time itself seems to drift slower, NASA's deep space cameras blinked, one after another, into nothing. What they had been watching was small, cold, and nameless to most of humanity. A visitor called 3I Atlas, the third confirmed interstellar object ever seen. A sliver of something not born of our sun, not bound to our gravitational spell, a messenger from elsewhere. Moments before it vanished, the data stream was alive with light curves and chemical traces, a flickering record of gases sublimating off its icy surface. But then, as the object slipped behind Mars, every feed went silent. No error message, no overload, just absence. The kind of silence that stretches beyond technology, that feels ancient, patient, aware. On Earth, the observatories continued to hum, unaware at first. Petabytes of cosmic data flowed through cables under oceans and deserts. Telescopes pivoted, focusing on the thin red arc of Mars as it transited the visitor's path. Then, one by one, the screens darkened. No signal from the deep space network, no reflections from orbiting satellites, no background static, as if the sky itself had folded shut for a breath. Astronomers in Pasadena stared into the voided feed. For a long moment, they didn't speak. The loss of telemetry was not unusual. Planets obscure, solar flares disrupt. Yet there was something unnatural in the symmetry of the silence. Every instrument across every frequency band failed at once. Even the redundant systems designed to overlap in coverage went mute. It was not just the absence of light, it was the absence of response. Even Mars's faint reflected glow, expected in the data, was gone, erased, as if occluded by an invisible hand. The first alert came from Goldstone, then Madrid, then Canberra, the global network of antennas that stitches together NASA's listening posts. Each reported the same impossibility. No downlink, no background noise, no cosmic microwave interference. The signal floor itself had dropped to zero, as if space had stopped vibrating. Behind the technical confusion lurked a slower, older fear, one that has lived with us since Galileo first lifted his telescope to the heavens. The fear that the cosmos is not only vast, but alive with things that can look back. For days, the scientists debated whether the silence was mechanical, environmental, or something more abstract, a data blackout caused by solar interference, or a brief alignment between Mars, the Sun, and an unknown particle field. But as systems rebooted and feeds reconnected, the void around Mars remained pristine. In the public briefings, NASA used careful language: temporary signal degradation, unanticipated electromagnetic interference, awaiting verification. But among the team, a quiet word circulated: erasure. Because 3I Atlas had not merely gone dark, its signal had dissolved, leaving no afterglow, no trace of dust, no reflected radiation, as if whatever it was, rock, ice, or artifact, had stepped out of existence the moment it crossed behind Mars. In the halls of the Jet Propulsion Laboratory, the disappearance became more than a technical anomaly. It became an omen, a whisper that somewhere, far beyond the reach of our equations, there are forces that can erase even the act of observation. The silence lingered in the data, like an afterimage burned into the eye of the universe. It wasn't merely absence, it was an echo of something that had never wanted to be seen. And yet, even as the screens flickered in empty black, the world kept turning. Mars continued its orbit, oblivious. Somewhere beyond, if beyond still existed, a fragment of alien ice and dust drifted, unseen, carrying with it the first great question of the new cosmic century. What happens when something not of this solar system enters ours, and then simply stops being there? The silence beyond Mars was not an ending, it was a beginning. It had been catalogued as 3I Atlas, a dry, procedural name that disguised the wonder it carried. The 3I stood for Third Interstellar, marking its lineage after Oumuamua and Borisov. But among astronomers, whispers spread that this object was different. It did not move like the others. It pulsed, it shimmered, and for the brief months it was visible, it seemed to rewrite everything we knew about visitors from other stars. The discovery began quietly, as so many revolutions do, a faint line on a telescope image, flagged by an algorithm designed to find near-Earth objects. The Atlas system, the asteroid terrestrial impact last alert system, had spotted it. A faint, elongated streak sweeping across the darkness between Jupiter and Mars. At first, it was assumed to be a distant comet, but within hours, its trajectory betrayed a truth far stranger. This was no solar wanderer bound by gravity. Its hyperbolic orbit declared it a drifter from the galactic deep, moving too fast, too freely to have ever called our sun home. It came from interstellar space, the cold gulf between stars, carrying the chemical fingerprints of a place no human eye had ever seen. At the University of Hawaii, where Atlas operates, the discovery spread through corridors in murmurs. Astronomers stayed through the night, watching the spectral readings roll in. The object's composition suggested volatile ices, carbon chains, and trace metals, but in ratios that defied local models. It was familiar enough to name, but alien enough to unsettle. Telescopes across the world pivoted to catch it before it slipped away. The Pan-STARRS Observatory, the Canada-France-Hawaii telescope, and eventually Hubble itself joined the chase. For a few precious days, Earth's collective gaze fixed on a tiny, flickering visitor, one speck of frozen possibility racing toward the inner system. In its first images, 3I Atlas glowed with a pale turquoise hue, unlike the crimson tails of typical comets. Its coma, the halo of gas surrounding its nucleus, expanded erratically, pulsing in brightness every few hours, as if responding to something unseen. Some scientists blamed rotational dynamics. Others suspected jets of gas erupting through its crust, but others saw a pattern. Hidden in the light curves, subtle intervals emerged, a rhythm, repeating with mechanical precision, not random, not natural, but structured, as though timed by intent. The data was noisy, uncertain, yet unmistakably rhythmic. The question no one dared voice in press releases began to whisper in private meetings. Was this merely geology and sunlight, or was this modulation, like a heartbeat? The official story remained grounded. NASA and the European Space Agency called for further spectroscopic analysis. Teams at JPL ran trajectory models backward, trying to pinpoint its origin. Each simulation painted a different map of the Milky Way, some tracing it to the Carina Arm, others to the space between star clusters in Lyra. But all agreed on one unsettling fact. Its journey had taken millions of years. It had crossed the galaxy's empty corridors longer than Earth had known mammals. For a moment, humanity looked up and remembered how ancient the cosmos truly was. When Oumuamua passed through in 2017, we had marveled at its strange shape and acceleration, at its refusal to fit neatly into the boxes of comet or asteroid. When Borisov came 2 years later, it was comfortingly familiar, icy, gassy, behaving as comets do. But 3I Atlas seemed to exist in the tension between those two, part natural, part anomalous. Its surface too reflective, its core too dense, its motion too deliberate. Even before the silence, something about it seemed to resist being understood. The more we measured, the less certain the numbers became. Its albedo shifted unpredictably, sometimes doubling within hours. Spectrographs showed spectral lines that flickered hydrogen and cyanide one moment, vanishing the next. a comet that changed its chemistry mid-rotation. Astronomers joked darkly that the object was answering back, but beneath the humor lay discomfort. They were measuring something that seemed to measure them in return. NASA's tracking division scheduled continuous observation as it approached Mars's orbital plane. Every hour, new data poured in: temperature gradients, mass estimates, trajectory deltas. Yet the closer it came, the less stable those readings became, like a compass needle trembling near a hidden magnet. In conference rooms lined with images of galaxies and probe trajectories, scientists debated whether the comet's energy profile was even consistent with known physics. The acceleration appeared non-gravitational, a force that could not be explained by solar radiation pressure alone. It had been seen before, faintly, with Oumuamua, but here it was undeniable. Something was pushing it. Dr. Alina Torres of the European Southern Observatory put it simply: it's not behaving like a rock, it's behaving like a choice. And then, as the calendars ticked toward the week of closest approach, an eerie anticipation settled over the global network of watchers. Mars would soon align with the path of 3I Atlas, eclipsing it from Earth's view for just 43 minutes. A brief, predictable occlusion, a routine moment of invisibility that happens in every orbital dance. But for some reason, no one slept that week. There was a sense, unspoken, irrational, that something was waiting for that shadow. When 3I Atlas vanished behind Mars, the world still thought it would re-emerge minutes later, bright as ever. But it never did. In those first quiet moments, when all seemed normal, the universe was about to change tone from light to silence, from knowing to not knowing. The mystery had arrived fully. And somewhere in the darkness behind Mars, a traveler older than language paused and was gone. The attempt to trace 3I Atlas's ancestry began as a mathematical exercise, a routine backward integration of its orbital parameters, the kind of computation every graduate student in celestial mechanics performs to locate an object's possible home. But as the simulations multiplied, they refused to agree. Each model sent 3I Atlas spiraling from a different corner of the galaxy, as if its path had been scrambled by invisible hands. Astronomers knew that gravitational tugs from passing stars, molecular clouds, or the Milky Way's central bar could easily distort an orbit that had lasted millions of years. Yet even accounting for those, something felt off. The error margins were not random. They seemed to cluster, converging not on a region of known stars, but on a void. Somewhere between constellations Lyra and Hercules, there lies an abyss. Astronomers call the Kepler Gap, a stretch of interstellar nothing where few luminous bodies dwell. That's where the equations led. The object, it seemed, had come from nowhere. At Caltech, Dr. Junpei Nakamura ran extended models that reached back 50 million years. His simulations suggested that 3I Atlas may have been expelled from a collapsing star system, one whose parent sun had long since burned out, a cosmic orphan traveling through the night between worlds. Its icy shell preserved the chemistry of a dead star's debris, like a fossil drifting through eternity. And yet, certain spectral readings contradicted that theory. The ratios of carbon isotopes pointed to a younger, more dynamic environment, perhaps a system rich in short-lived radionuclides, something impossible to reconcile with a long-dead sun. Some even speculated the object had been made rather than formed, a product of physics not yet understood. The debate deepened when infrared data from the James Webb Space Telescope hinted at structured reflections across the object's surface, faint, grid-like interruptions in its thermal emission. To some, these were artifacts of data compression. To others, they resembled patterns of engineered symmetry. The media, eager for wonder, called it the alien lattice. Scientists, careful and exhausted, called it noise. But beneath the terminology lay a quiet tremor of possibility. From an evolutionary perspective, interstellar comets were supposed to be fragments, leftovers from planetary formation, debris flung outward during the birth of new worlds. Each one should carry the signature of its nursery, traces of ammonia, water ice, hydrocarbons, silicates. But 3I Atlas broke that pattern. It contained crystalline hydrogen, something that can exist only at temperatures near absolute zero and pressures no comet should survive. That meant it had traveled through regions colder than any known interstellar medium, colder even than the cosmic background itself. Its ancestry began to look less like a linear history and more like a riddle. Perhaps it was born not from a sun, but from something else entirely, a relic of the galactic halo, or an artifact from the epoch when the first stars collapsed and recycled their ashes into new matter. Some theorists proposed an even bolder idea, that 3I Atlas was a piece of dark matter made briefly visible ordinary dust crystallized around an exotic core of non-baryonic substance. If true, its existence would bridge the most elusive mystery of cosmology, the invisible scaffolding that holds galaxies together. At the Jet Propulsion Laboratory, physicists pored over photon-scattering data, searching for anomalies in polarization that could hint at an exotic core. The readings were inconclusive, neither confirming nor denying, but a subtle asymmetry persisted, suggesting the interior was denser than any ice could allow. And still, its path through space seemed chosen. Every interstellar visitor before had obeyed the random violence of galactic motion. But 3I Atlas traced a trajectory that grazed the orbital planes of all four inner planets, as though threading through the solar system with deliberate geometry. The odds of such alignment by chance were infinitesimal. NASA's orbital dynamics team called it a cosmic coincidence. Others, quietly, called it choreography. By then, 3I Atlas had become an obsession. Even the most stoic scientists confessed a sense of presence of something that was not merely passing through, but observing in return. Every telescope array on Earth and in orbit aimed its eyes toward it. Keck, VLT, Hubble, Webb, all peering into the same fragile blue arc of the night sky. And as the data poured in, it painted a portrait that refused to settle. Its surface, once thought to be irregular, revealed facets, planes that caught and reflected light like polished mirrors. Its albedo changed with uncanny precision, brightening and dimming in harmonics that mimicked the sidereal rotation of Mars. As though the object was responding to the gravitational fields around it, adapting its spin to match them. No known natural body does this. The planetary scientists who had studied comet dynamics for decades began to feel they were witnessing a kind of language, not of words, but of motion and light. Each flare, each dimming, seemed to correspond to a shift in trajectory or solar proximity. When plotted, the intervals formed curves resembling mathematical constants phi, e, pi, the fingerprints of structure, not chaos. But correlation is not causation. They reminded themselves of that mantra daily. They were scientists, not mystics. And yet, behind every dataset lay an unspoken wonder. If the universe ever did attempt to speak, what would it sound like? Would it not use the same instruments it gave us to discover it light, gravity, and silence? In ancient mythology, comets were omens, messengers of change. In this new century, 3I Atlas seemed to resurrect that role, a celestial envoy, not of superstition, but of cosmic strangeness. Its ancestry, though untraceable, whispered of an older order of matter, one that remembers before stars, one that travels not to be seen but to remind. And so, even before it vanished behind Mars, the story of 3I Atlas had already ceased to be about discovery. It had become about inheritance of the cosmos, reminding us that not everything within it needs to come from somewhere. Some things may simply arrive. It shimmered like something caught between being and not being. 3I Atlas, the faint turquoise wanderer, tracing a path so deliberate it seemed almost choreographed. As the days passed, its behavior grew more erratic. Every telescope that watched it noted the same anomaly. The object was accelerating, but not in a way any natural comet should. For ordinary comets, the explanation is straightforward: sublimation. As sunlight warms their icy nuclei, jets of vaporized gas push outward, creating the familiar tail and subtly altering trajectory. Yet the force this time was too strong, too consistent, and most disturbingly, too precise. Instead of random jitter, 3I Atlas's motion followed a mathematical pattern, a curve that mirrored the gravitational contours of the Sun and Mars, as if it were reading the invisible geometry of spacetime itself. When physicists plotted the change, the line curved not chaotically, but symmetrically smooth, continuous, elegant. The equations describing it resembled those of a spacecraft performing gravity assist maneuvers. It was as if the comet was flying. NASA's orbital analysts ran simulations again and again, each time double-checking their constants: solar flux, outgassing coefficients, rotational spin, angular momentum. The math refused to balance. There was more acceleration than the Sun could provide. Dr. Elise Rahman at the Goddard Space Flight Center put it bluntly: "It's not propulsion as we understand it, it's surrender. Something in its structure yields to the curvature of space more easily than ordinary matter does." That idea unsettled even the theorists. Matter yielding to curvature implied a material with relativistic flexibility, something that bends with space-time rather than resists it. No known solid behaves this way. In the following weeks, every observatory in the world tuned in. Amateurs from Chile to Japan reported flickers in its luminosity, timed with uncanny regularity, 8-minute pulses, then 13, then back to 8. The pattern was stable for days before abruptly shifting again. It was as if the object was whispering in code. The first spectrographic surprise came from the infrared telescope facility on Mauna Kea, a faint emission at 21 microns, consistent not with dust or vapor, but with structured interference, as if the light was being diffracted through a grid finer than any crystal lattice. When the data was peer-reviewed, it split the community. Half of the scientists insisted it was a computational artifact, noise from the imaging pipeline. The other half stared at the graphs in silence, unwilling to name what they thought it meant. At Hubble, 3I Atlas appeared to flare briefly, then dim, then flare again. Some said it was rotation, others believed it was signaling. The press, eager to romanticize the unknown, called it the blinking comet. But within NASA, the tone was somber. The object's unpredictable light made calibration impossible. The data it reflected was becoming self-contradictory, as if the more we looked, the less certain its existence became. And beneath it all lay a deeper whisper, the uneasy memory of Oumuamua. That first interstellar visitor had also accelerated inexplicably. It too had left scientists in quiet awe and discomfort. But Oumuamua had slipped away, fading into the darkness with no trace. Now, the universe seemed to be repeating itself with more clarity and more defiance. The theories multiplied like galaxies. Perhaps 3I Atlas contained trapped hydrogen, releasing energy as it thawed. Perhaps it carried magnetic minerals responding to solar wind. Perhaps, as a few dared to suggest, it wasn't a comet at all but an artifact. When Avi Loeb, the Harvard astrophysicist known for challenging convention, was asked about it, he only smiled faintly and said, "We should not assume that nature is limited to what we have seen." Still, in scientific circles, even whispering the word artifact was taboo. To imply design was to step into the territory of philosophy, even theology. And yet, there it was, the possibility lingering like a static hum behind the data. Some nights, the object seemed to vanish from optical view, only to reappear hours later as though flickering between states. In radio frequencies, it was equally elusive, producing brief, structured emissions followed by long silences. When plotted against time, those bursts formed a pattern resembling a decaying exponential, the same curve that describes the cooling of radioactive material or the fading heartbeat of a dying star. What then was dying? In Cambridge, a group of astrophysicists proposed that 3I Atlas was a fragment of a neutron star's crust, flung loose during a cataclysmic merger millions of years ago. Such fragments could, in theory, retain magnetic fields strong enough to distort local spacetime and mimic propulsion, but even that couldn't explain the rhythm of its pulses. Meanwhile, the public imagination soared. Artists painted it as a celestial seed. Poets called it the messenger of the in-between. Documentarians, like the one this script will become, began to prepare narratives of cosmic introspection, of how fragile our understanding of the universe truly is. And yet, in the halls of mission control, amid glowing monitors and quiet keystrokes, the mood was not poetic but tense. Every minute, the comet approached Mars, and the instruments were tasked with watching every flicker, every spectral anomaly, every curve of trajectory. One engineer at the Deep Space Network later described it like this: "We were staring at something that didn't want to be stared at." The closer 3I Atlas drew to Mars, the more erratic its readings became. Its tail, faint at first, began to fragment not naturally, but in discrete lines, like filaments aligning to magnetic fields. Radio echoes from the region arrived milliseconds earlier than predicted, as though space itself was slightly compressed near the object. The universe seemed to ripple around it, softly, invisibly. Then, just before occultation, when Mars's red disk began to slide across its path, the comet flared one final time. Its brightness surged to nearly twice that of expected solar reflection. For a few seconds, telescopes across Earth recorded the same impossible image, a geometric halo, hexagonal, symmetrical, glowing in the thin light of the Sunday. And then, nothing. The light went out. The data flatlined. No fading tail, no residual signature. A blink and an entire interstellar body ceased to exist. For the first time since humanity began listening to the stars, we witnessed not the death of a celestial object, but its disappearance. When 3I Atlas slipped behind Mars, there was no sense of drama, no flash, no flare, no cosmic thunderclap, just a steady progression of numbers across NASA's telemetry screens, a sequence of stable signals documenting the alignment of two worlds. Then, in the span of less than a second, every graph fell still. Telemetry feeds from the Deep Space Network froze, each antenna reporting identical losses across multiple frequencies. The Canberra complex, facing the rising Martian arc, was first to notice the anomaly. Engineers checked solar interference warnings, scanning for spikes in radiation, but the sun's readings were calm, unremarkable. At the same moment, Madrid's antennas reported the same dropout, followed within seconds by Goldstone in California. All three ground stations, separated by oceans, experienced the exact same failure pattern, not static, not distortion, but a perfect, uniform null. For a moment, no one panicked. These systems were old veterans of silence. Communication blackouts were part of deep space life. There were rules for them. procedures, even a rhythm, pause, diagnose, reconnect, but this time, the usual recovery commands returned nothing. In the control rooms, banks of monitors cast ghostly light on faces drawn with disbelief. One technician whispered that it looked less like a signal drop and more like the universe had muted itself. The engineers tried everything: frequency sweeps, reboot protocols, signal amplification. The void remained absolute. No background radiation, no cosmic microwave hiss, no ambient radio echo from the Sunday. It was as though the very medium of transmission had vanished. When the first optical data was reprocessed, the situation deepened into absurdity. Mars itself, which should have filled the field of view, appeared distorted. The planet's limb, the delicate curve of its edge, was smeared as though seen through water. Instruments calibrated against stellar backgrounds failed to align. Stars near Mars's orbit wavered slightly, as if refracted by an invisible lens. NASA's official term for this was localized data corruption, but internally, another term circulated: field collapse. At JPL, astrophysicist Dr. Marisol Grant studied the raw stream before the blackout. She noticed something odd milliseconds before the silence. 3I Atlas emitted a faint gamma spike, too weak to register as a burst, but strong enough to alter the telemetry timestamp. That pulse, almost imperceptible, had preceded the total blackout by precisely 0.41 seconds. It was not random. When news of this anomaly reached the Space Science Institute, theorists began to whisper about causal paradoxes. Could the object have produced a burst that not only disrupted instruments but altered the behavior of light itself? In Houston, mission controllers analyzed Mars's atmospheric reflections, hoping to find a trace, any indication that the comet's shadow had passed across the red planet's thin veil, but no such shadow existed. The expected albedo change, a slight dimming on the Martian surface, never occurred. Whatever had passed behind Mars, it had taken even its reflection with it. Within 48 hours, NASA issued a preliminary statement calling the event an unexpected data anomaly, coinciding with the occultation of interstellar object 3, Atlas. But those who had seen the raw feeds knew it was more than that. Somewhere behind the formal language was a dawning realization: we had just lost contact not only with an object, but with a part of space itself. In the following days, the phenomenon spread. Deep space observatories reported a thin corridor of radio silence extending outward from Mars's orbital path, as though a shadow of silence had been cast through the solar wind. Communication with satellites passing near that vector briefly degraded, then recovered, leaving no permanent damage but plenty of unease. The European Space Agency's Mars Express recorded faint fluctuations in its magnetometer readings during the same window, minute changes in field intensity, suggesting that Mars's magnetic tail had been brushed by something powerful and transient. To the human mind, such abstractions are hard to grasp. What does it mean when emptiness deepens, when even silence gains structure? As the days turned into weeks, attempts to reacquire 3I Atlas grew desperate. Telescopes swept the sky along every predicted trajectory. Nothing, no dust, no debris, no spectral trace. It was as if the object had never existed. The astrophysical models began to break. Conservation laws demand continuity. Matter cannot simply vanish. Energy cannot be destroyed. Yet the data insisted otherwise. In every measurable sense, the object had exited reality as we define it. The metaphor that circulated among the scientists was an ancient one: a stone dropped into water, leaving no ripples. Still, amid the failure, a few whispered that perhaps the data wasn't missing, it had simply gone somewhere else. There were subtle hints, minute timing irregularities in signals from unrelated probes, slight drifts in atomic clocks across Earth, based observatories, barely perceptible but synchronous with the blackout. Something, it seemed, had nudged the rhythm of time itself. At the time, no one dared to suggest it publicly. To speak of time distortion was to trespass into realms reserved for theory, not observation. But in private, some scientists confessed that they felt it that the loss of 3I Atlas wasn't a failure of instruments, but of reality's continuity. The event acquired an informal name within NASA, the Mars Veil, a phrase spoken in meetings, never written in memos. It described not what was known, but what was felt, that some veil had descended between us and the thing we were watching, and that beyond it, something had moved. The silence lasted 27 minutes. Then, gradually, the noise returned. Static, weak telemetry, the faint hiss of the cosmos, ordinary space, restored. But 3I Atlas was gone. When the data streams finally normalized, Mars shone, once more, steady, unbothered, wrapped in its red serenity. Yet those who had witnessed the blackout could not forget the sensation, the moment when reality blinked and all the instruments fell quiet, as if in collective awe. It was not a malfunction, it was a moment of erasure, as though the cosmos had briefly edited itself. And somewhere, behind the quiet red planet, the universe had just whispered back. In the hours after the disappearance, the silence became a presence of its own. The control rooms, once filled with the quiet hum of machines translating the cosmos into data, now breathed a different kind of stillness, the kind that feels like being watched. For the first time in decades, NASA's Deep Space Network, the most powerful listening system humanity had ever built, was deaf to the heavens in a direction that should have been ordinary. They called it a data desert. Rows of servers continued to record nothing. Charts scrolled across monitors, flat and empty. Time itself rendered meaningless, without a signal to mark its passage. Engineers combed through code and command logs, desperate for a mechanical cause. They found none. In Madrid, a systems analyst named Rafael Ibarra replayed the final seconds of the last feed. He noticed that just before the blackout, the noise floor of the receivers, the faint hiss of cosmic background radiation began to drop. Normally constant, the microwave hum of the universe dipped by nearly 20%, like sound being swallowed by an invisible curtain. That alone should have been impossible. Background radiation is the oldest music in existence, the afterglow of the Big Bang itself. It doesn't drop, it doesn't vanish, but on that day it did. Raphael wrote in his internal report, "It's not that we lost signal, it's that the universe stopped speaking." At the same time, the Hubble Space Telescope attempted to reacquire visual contact, scanning the predicted re-emergence point of 3I Atlas as Mars moved aside. Nothing appeared. The field was not merely empty, it was cleaner than expected, devoid of even the faint interplanetary dust that always hovers in background images. The region looked sanitized. Days later, the James Webb Space Telescope turned its gaze toward the same coordinates. Its instruments, designed to see the faintest whispers of light from the dawn of time, found nothing but coldness, a perfect absence of infrared emission. It was as though something had consumed the warmth of the void itself. The astrophysicists began to use an uncomfortable word, anomaly. Officially, that term is neutral, a placeholder for "we don't know yet." But within the community, it carries a deeper tone. It means this should not exist. Across the Atlantic, data from ESA's solar orbiter began to show minute fluctuations in the solar wind along Mars's orbital track. The plasma density thinned, briefly, by fractions of a percent, subtle, but consistent with a disturbance that had physically displaced charged particles. It was as if a corridor of emptiness had passed through space, invisible but tangible, carving a wound into the solar flow. This corridor was narrow, less than a few thousand kilometers wide, yet its shape matched precisely the trajectory of 3I Atlas, and the timing aligned perfectly with the blackout. Something had moved through that space and left behind not a trail of matter, but of nothingness. The working theory, for lack of anything better, was interference, a total electromagnetic suppression caused by a field of unknown origin. But that explanation begged a deeper question. Interference with what? For interference to exist, two signals must collide. If one of them was ours, then what was the other? In the weeks that followed, the search continued. Hundreds of telescopes, ground-based and orbital, were retasked to scan the Martian sector. Data poured in, and every bite told the same story. Silence. But then came the whispers, the small, irregular pulses detected by the Deep Space Network during system calibrations. Not proper signals, not even measurable at first, just faint tremors in the data, like echoes of something that had once existed. Engineers called them phantoms, assuming they were electronic ghosts of the previous transmission. But when cross-checked between stations, those same phantom pulses appeared simultaneously across the globe, separated by tens of thousands of miles. That should have been impossible. For a week, no one spoke of it officially. Then, Dr. Noura Chowdhury, a physicist at JPL, published an internal memo describing the patterns as statistically coherent across non-connected instruments. In other words, they were not noise, they were structure. It was as though the silence itself had begun to hum faint, rhythmic, and deliberate. The press never heard of this, not at first. NASA's public relations team released calm updates about data recalibration and ongoing analysis. But within the laboratories, the tone shifted from curiosity to awe. The world's most advanced instruments were staring into an emptiness that seemed to organize itself. One night, around dry RM, at Goldstone, an engineer running a spectral cleanup filter noticed a harmonic pattern hidden inside the static faint peaks, spaced evenly at 1,420 MHz, the hydrogen line, the most fundamental frequency in the cosmos. It was hydrogen, or something pretending to be. He isolated the signal, ran it through Fourier transforms, and found modulation pulsing like a heartbeat, spaced exactly 1.618 minutes apart, the golden ratio, again, the same pattern once seen in the brightness curves of 3I Atlas itself. Coincidence? Perhaps. But in science, enough coincidences begin to look like a message. The following morning, the engineer submitted the data for review. The file vanished from the internal server within hours. Officially, it was a technical error, corrupted, unrecoverable. But the staff began to whisper that the anomaly had followed them into their machines. By the end of that month, more systems began to behave strangely only in that direction of the sky. Minor timing drifts, subtle frequency shifts, calibration mismatches, as if every instrument that looked too long began to inherit the silence. It wasn't sabotage. It wasn't interference. It was contagion. The universe, it seemed, had found a way to make its absence spread. And in that spreading void, the question deepened into something that no physicist, philosopher, or engineer could answer. What if silence is not the lack of communication, but a different kind of language altogether? It began as a whisper in the data, faint, fragile, but unmistakably structured. Weeks after the blackout, when the silence around Mars had become routine, a low-level systems check at Goldstone revealed something that should not have been there: a pulse. It was weak, nearly indistinguishable from static, but it carried rhythm, not noise rhythm. The engineers, trained to distrust coincidence, re-ran the test. The pulse appeared again, slightly shifted in phase but identical in structure. It wasn't a reflection, nor was it random cosmic interference. It was organized. They called it an anomalous burst, filed it under routine noise for the sake of paperwork, and quietly forwarded it to the Deep Space Network's signal analysis team in Pasadena. Within 48 hours, similar bursts were detected at Canberra and Madrid, all arriving within milliseconds of one another, synchronized across hemispheres, impossible for any terrestrial source. Each pulse lasted exactly 1.618 seconds. The golden ratio, once more the same ratio that had haunted the light curves of 3I Atlas before it vanished. No one could ignore the symmetry anymore. The first scientist to raise her voice publicly was Dr. Noura Chowdhury, whose earlier memo on coherent phantom signals had been dismissed as a calibration error. She presented the new data to a closed NASA review board. Her words were careful, deliberate. This is not residual noise. It is a pattern of intent, a structured sequence emerging from a region of null signal. If the absence of 3I Atlas was physical, these bursts may be its shadow. The board fell silent. They had no framework for a phenomenon that behaved both like a signal and like the echo of something that had been erased. To test the theory, the Deep Space Network directed 3 antennas to triangulate the bursts. The results were eerie. Each pulse seemed to come from the same coordinates behind Mars, where 3I Atlas had vanished, but their apparent source shifted subtly each day, tracing a spiral path outward, as though something unseen were expanding from that point. A ripple, a wave in the fabric of space. Physicists began calling it residual emission, but it didn't behave like ordinary radiation. Instead of fading with distance, it oscillated, waxing and waning with regular intervals, as if breathing. Meanwhile, radio astronomers at Arecibo, before its eventual collapse, had recorded faint harmonics of the same signal months earlier, buried in archived data. When processed, those harmonics aligned perfectly with the golden ratio timing sequence. Whatever this was, it had been speaking before we knew to listen. In the following weeks, more instruments joined the search. The Parkes Observatory in Australia detected low-frequency tails accompanying each pulse, strange, subsonic waves that resonated through the ionosphere, briefly disturbing GPS satellites. Even the most conservative data analysts admitted the pattern's coherence exceeded anything random. One scientist described it like this: "It's as though the silence is beating like a heart beneath the skin of the cosmos." Still, most refused to use words like signal. They called it modulated noise, post-event interference, anything to avoid the implications. But the numbers spoke for themselves. When the Fourier transform of the burst was visualized, it revealed a curious symmetry, twin peaks mirrored across the hydrogen line, equidistant and stable. That symmetry matched the mathematical description of an information carrier wave, the basic architecture of communication. If the bursts were natural, nature was speaking in the syntax of intelligence. It was around this time that rumors began leaking to the press. Fringe outlets published headlines about ghost signals from Mars and NASA's missing comet speaking from the void. Most scientists ignored them, but a few within the agency wondered whether the leaks were deliberate, an attempt to test public reaction before releasing the truth. Because the truth was uncomfortable. The pulses were not random, not isolated, and not dying. They were increasing slowly, predictably, almost patiently. Over the next month, the bursts grew longer, their intervals shorter, until the golden ratio sequence inverted. What had been 1.618 seconds became 0.618, the reciprocal. It was as if the pattern were folding in on itself, collapsing toward an equilibrium. And then came the message. During a late-night analysis run at JPL, a junior researcher applied an autocorrelation algorithm to the amplitude envelope of the pulses, a trick often used to detect repeating subpattern. What she found made her stop breathing. Embedded within the modulations was a sequence of primes 2, 3, 5, 7, 11, 13, spaced with perfect accuracy. The universal fingerprint of mathematics, the one code no intelligence could mistake for randomness. It was the same kind of structure that the Arecibo message had broadcast from Earth in 1974, meant to prove our existence to whoever might be listening. Now, 50 years later, something seemed to be sending the idea back. The discovery was buried in internal reports, encrypted, shared only among a handful of researchers. The public would never hear of it. Officially, NASA dismissed the bursts as cross-satellite signal contamination, but within private networks, a different understanding emerged. If 3I Atlas was gone, then whatever was behind Mars now, or whatever had replaced it, was using its path as a conduit. It was not sending sound or light, it was sending structure. Over time, a few brave theorists began to whisper the unthinkable, that the object had not vanished at all, but transformed, not destroyed, not moved, but transposed into a domain where space and time no longer obey our definitions. In that domain, light could be silent, information could be absence, and silence itself could sing. When the pulses began to spread through the network, science fractured. It was not the first time reality had forced physicists to choose between competing impossibilities, but rarely had the division cut this deep between those who believed the anomaly was mechanical and those who whispered that the laws of nature were breaking their own vows. The first camp clung to pragmatism. They argued that 3I Atlas's disappearance was nothing more than coincidence layered upon technical failure, a solar event, perhaps a coronal mass ejection scattering charged particles across the inner solar system, temporarily muting deep space telemetry. It was the kind of answer that comforted engineers, neat and testable. But the numbers refused to behave. The sun had been quiet, no flares, no radiation spikes, no geomagnetic storms, and yet the blackouts persisted, faint and intermittent, always aligned to that same vector, the one that pointed toward the invisible wake of 3I Atlas. The second camp, the quiet rebels, began to wonder whether something beyond our instruments had occurred. Among them were astrophysicists, quantum theorists, and a few reluctant philosophers who still believed that the universe might hold secrets too elegant for immediate comprehension. They called themselves the Divide. In small, encrypted meetings never recorded, never acknowledged, they proposed ideas that bordered on heresy. What if the anomaly was not the absence of data, but the appearance of something new, a distortion of field space, or a fold in the electromagnetic continuum? At one such meeting, Dr. Marisol Grant presented a set of equations that silenced even the skeptics. Using gravitational mapping from Mars orbiters, she had discovered a faint, transient shift in local curvature coinciding with the blackout. It was infinitesimal, barely measurable, yet consistent across multiple instruments. The implication was staggering. Mars's own gravitational field had rippled. For the next several days, that data circulated among the Divide and leaked, inevitably, to the mainstream. When the story broke, the headlines screamed of gravitational disturbances near Mars. NASA downplayed it as instrument recalibration. But deep within the agency, a different tone prevailed. The gravitational anomaly was real. Something behind Mars had warped the fabric of spacetime, however briefly. If it had mass, it wasn't measurable. If it had energy, it wasn't visible. It was simply there, bending everything around it without ever announcing its own presence. The skeptics countered with plasma physics. They suggested a magnetic anomaly, perhaps from interactions between solar wind and Mars's residual magnetosphere. Plasma waves could, in theory, mimic gravity fluctuations. Yet even plasma obeys continuity. These signals did not. Each reading faded abruptly, like an engine shutting off between pulses. It was this stop-start rhythm, the heartbeat of the void, that terrified even the most grounded scientists. Nature doesn't pulse, machines do. Across institutions, the tone shifted from curiosity to defense. NASA, ESA, and Roscosmos issued joint confidentiality directives, restricting access to raw telemetry. To the public, the narrative remained stable, data loss due to interference. But in private corridors, the divide expanded. Some claimed that what had happened was a lensing event, a brief gravitational mirage caused by the alignment of three, Atlas, Mars, and the Sunday. If true, it could explain the light distortions, the data gaps, even the apparent disappearance. But lensing cannot silence radio signals, nor can it erase background radiation. Others proposed that 3I Atlas had encountered a region of exotic matter, a field of negative energy density, capable of bending spacetime inward. In this scenario, the comet could have fallen into a pocket of altered geometry, not destroyed, but displaced, folded into an unobservable dimension of the same universe. The more extreme voices, still scientists, still cautious, suggested something more poetic, that 3I Atlas had crossed a phase boundary between realities, that the cosmos might be a layered structure, and the object had found a door where none should exist. To them, the pulses were not a warning, but a signature the resonance left when something moves from one layer to the next. There was precedent for such thought, though it was buried in the forgotten margins of theoretical physics. In the 1980 seconds, papers had speculated on quantum vacuum tunneling, the idea that empty space itself could shift into a lower energy state, like ice melting into water. A false vacuum decay, they called it, capable of rewriting the constants of the universe in an instant. What if 3I Atlas had been a catalyst, a fragment of some distant realm where the laws differ just slightly? What if its presence here was incompatible with our version of reality, forcing space-time to defend itself? The idea spread like fire. It was madness, yes, but elegant madness, the kind that sometimes turns out to be true. Still, others warned against myth-making. They pointed out that every civilization before ours had interpreted celestial anomalies as omens, as divine punishment, as messages from gods. Now, in the 21st century, we had simply traded gods for equations. The impulse was the same. And yet, the facts refused to die. Mars's magnetic field continued to quiver. The pulses continued, faint but stubborn. The region behind the planet remained radio silent except for those structured bursts, as if the void itself were breathing. A pattern emerged. The intervals between bursts matched the orbital resonance of Mars itself. 687 days divided by Fibonacci ratios. It was a rhythm hidden within planetary time, a conversation encoded in celestial motion. Coincidence, perhaps, but the divide stopped believing in coincidence. Some began to say, not publicly, not even in official memos, that what had vanished was not a comet, but a boundary. That 3I Atlas had been a hinge between universes, and when it closed, the silence was the sound of separation. In the end, NASA's official stance was safety. Observation of the region was suspended pending interference mitigation. But those who had listened longest refused to stop. In basements, in university labs, in silent observatories scattered across the Earth, small groups continued to monitor the frequencies. They had learned to expect the silence, to wait for the next heartbeat of the void. Each time it came steady, patient, mathematical, they felt the same quiet awe. Something was still out there, they knew. Not gone, not dead, just waiting beyond the veil of Mars. And it was still speaking. The deeper the silence grew, the more physicists turned to the oldest language of the cosmos, relativity. Einstein's vision of space-time, a seamless fabric stretched and curved by mass, had long been our compass through the strangeness of gravity. If 3I Atlas had truly vanished, perhaps it had slipped not into another place, but into another shape of space. Dr. Marisol Grant, still sleepless after the weeks of anomalies, began to reframe the problem. What if, she asked her team at JPL, we're not seeing an object disappear, we're watching a coordinate system fail? To Einstein, matter and energy do not exist in spacetime, they define it. When mass moves, it bends the stage beneath it. Light follows the curve, and what we see is the illusion of gravity. But in the equations, there is room, a delicate, terrible room, for certain shapes of curvature that close in upon themselves. Loops of geometry where time and direction fold back like origami. Wormholes. The word itself carried danger. Science had spent a century dancing around it, aware of its mathematical legitimacy, but terrified of its narrative magnetism. Yet what other geometry could explain the ripple detected near Mars, the slight but genuine distortion in the planet's gravitational profile, followed by the absolute disappearance of mass? A lensing event, yes, perhaps, but this time the lens had swallowed the light it bent. NASA's relativists began running spacetime simulations using the last known data from 3I Atlas's trajectory. The results were unsettling. As the object approached Mars, its path intersected a region of theoretical instability, a point where solar and Martian gravities formed a subtle resonance, an equilibrium known as a Lagrange saddle. Normally, these are calm pockets where spacecraft drift safely. But in some relativistic models, under extreme conditions, such balances could create microcurvatures, spacetime eddies, invisible whirlpools where the geometry of the universe becomes thin. Perhaps 3I Atlas had found one. If so, it would not have fallen through space, it would have fallen out of it. To visualize this, the team used a relativistic ray tracing simulation, mapping photon trajectories through curved spacetime. What they found chilled them. Near the coordinates of disappearance, the model predicted a localized Einstein ring, a circle of distortion formed when light bends around a dense mass. Yet the density required to produce such an effect was impossible, equivalent to several Earths compressed into a point no larger than a city. No such mass existed there, but the geometry did. It was as if something unseen, intangible, had momentarily warped the universe and then vanished, leaving only its curvature behind. Einstein had once called gravity geometry in motion. If he were alive, he might have smiled at the irony. Here was geometry, moving again, writing in a dialect too subtle for our instruments. When the Deep Space Network reconstructed the missing telemetry, they noticed a tiny phase shift, a consistent delay of 38 microseconds between stations, far beyond synchronization error. If plotted spatially, that delay corresponded to a curve, not a line. The network itself had been bent, like light around an invisible mass. The equations suggested a brief, reversible contraction of space, a localized reduction in metric distance. For a fraction of a second, the distance between Earth and Mars had shortened by less than a millimeter, an imperceptible twitch in the skeleton of the cosmos. The data was fragile, but its implication was clear. The silence had weight. Einstein had warned of such things. In his field equations, certain solutions allow for closed time-like curves pathways through spacetime where cause and effect intertwine. In most universes, they cannot exist without exotic matter, negative energy, or something worse. But what if 3I Atlas was exotic matter? a shard of the universe's deep machinery, wandering through normal space until encountering a resonance that sent it home. This idea, absurd yet elegant, began to circulate quietly. The comet wasn't a visitor. It was a traveler returning to its own dimension, its own curvature. We merely watched it cross the threshold. To test this, physicists analyzed how Mars's reflected sunlight behaved in the minutes following the blackout. Curiously, the planet's red albedo had shifted subtly, briefly toward the blue end of the spectrum. Blue shifted light means one thing: movement toward the observer. For those 40 minutes of silence, Mars had appeared infinitesimally closer to Earth. A planet cannot move that way, but space-time can. It was a microscopic echo of relativity itself, proof, perhaps, that we had witnessed a real, physical contraction of the space between worlds, the kind Einstein described in his thought experiments of collapsing stars and speeding clocks. The realization spread slowly, like frost across glass. The universe had flexed. And then came a deeper terror. If space-time could bend that easily, what else might fall through the seams? What else had already? Stephen Hawking's warnings about wormholes returned to the surface. He had argued that nature abhors them, that quantum effects would cause any throat in space-time to collapse instantly, preventing paradoxes. But what if the cosmos had exceptions? What if 3I Atlas was not destroyed by the collapse, but escorted through it? At Cambridge, theoretical physicist Elias Novak offered a haunting interpretation. We didn't lose an object, we lost connection. Space itself tore in a way we can't yet measure, and that tear sealed before light could escape. The world's observatories turned their eyes to the region again, not seeking 3I Atlas, but signs of gravitational lensing, radiation echoes, any aftershock of curvature. None appeared. The geometry was clean, restored, silent. And yet the silence remained strange, too perfect, too symmetrical, as if the fabric had been patched, the hole sewn shut by something that preferred invisibility. In private memos, a few dared to write the forbidden phrase, artificial lensing event, a manipulation of space-time too elegant to be accidental. But most scientists recoiled. They needed not belief, but mathematics. And in the mathematics, relativity still ruled supreme, the stern voice reminding us that the universe owes us no comfort, only consistency. Still, late at night, when the equations fell silent and the screens dimmed, some could not escape the thought. Perhaps Einstein's geometry was not a static map, but a living thing, an ocean that breathes. And perhaps 3I Atlas had simply found the tide. If relativity described the bending of the cosmos, quantum theory whispered of its dissolving edges, a place where certainty ends and possibility begins. As the equations of spacetime failed to contain the disappearance of 3I Atlas, the focus shifted to the other half of physics, the invisible machinery beneath reality itself. For the scientists of the divide, the objects vanishing no longer belonged to the realm of gravity or mass. It had become a question of existence, or, more precisely, coherence. Quantum mechanics has always spoken in riddles. At its smallest scales, reality behaves like a conversation between possibilities, particles existing in multiple states, locations, and even times until observed. The act of measurement collapses the cloud of potential into a single truth. But what happens, physicists began to wonder, when the act of observation itself falters? Could something simply unmeasure itself? That idea, once philosophical poetry, now demanded mathematics. Dr. Noura Chowdhury was the first to frame it aloud. If the wave function describes everything, she said during a private symposium at CERN, then perhaps 3I Atlas didn't disappear. It decohered. It stepped outside of observation. The words unsettled the room. In quantum theory, decoherence is a mundane concept, the process by which fragile quantum superpositions collapse into classical reality. It explains why atoms behave quantum mechanically, while planets and people do not. But what if an object, an entire interstellar body, could reverse that collapse? What if, under some extraordinary condition, the macro world briefly returned to its quantum uncertainty? Somewhere in the silence behind Mars, the impossible might have happened. A comet that ceased to exist, not because it was destroyed, but because the universe could no longer decide whether it was there at all. The evidence, faint but teasing, began to appear in the data. The residual pulses, those rhythmic bursts emerging from the void, displayed not a single frequency, but a cloud of probabilities, spectral lines overlapping, shifting, blending, as though broadcasting multiple realities at once. When plotted, their distribution resembled the interference pattern of light passing through twin slits, a hallmark of quantum duality. NASA's signal analysts called it noise in frequency space, but to quantum physicists, it looked eerily like a superposition, the signature of something existing in many configurations simultaneously. One researcher likened it to a cosmic version of Schrödinger's cat. 3I Atlas was both there and not there, depending on whether the universe was watching. The philosophical implications rippled outward. Observation, in quantum theory, is participation consciousness and measurement intertwined. Perhaps, as the object passed behind Mars, the combined geometry of planetary shadows and solar radiation formed a zone where no direct observation was possible. For that brief window, the universe's gaze had turned away, and the object slipped into the uncertainty from which everything originally comes. It wasn't destruction, it was reversion. Others took the idea further. Dr. Ilyas Novak proposed that the 3I Atlas event might represent a form of quantum entanglement on cosmological scales. If matter can be entangled across light years, a possibility suggested by emerging research, then the comet could have been paired with a twin somewhere in the galaxy. When one was measured, the other responded. If one decohered, both would vanish from each other's universes. Perhaps, Novak speculated, what we witnessed was an echo of that entanglement resolving itself, a cosmic system seeking equilibrium. Still, most physicists recoiled from such metaphysical ground. It was too large, too poetic. Yet the mathematics supported the ghost of the idea. The uncertainty principle scaled upward, whispering that the line between the quantum and the cosmic may not be as sharp as we pretend. For decades, theorists have speculated that spacetime itself is quantized, a granular structure made of Planck-scale atoms of geometry. If that were true, then the boundary between existence and absence might be less rigid than we imagine. 3I Atlas could have found one of those cracks, a pixel gap in the fabric of the universe, and dissolved between frames. To most people, these ideas sounded like science fiction. To the physicists awake at 3 a.m., staring into the smooth silence of the data, they sounded uncomfortably logical. One evening, Dr. Chowdhury ran a simple simulation: what would happen to a coherent wave packet passing through a region of fluctuating gravitational curvature, like the one near Mars. The result? Interference. The simulated object's quantum field became unstable, spreading into a haze of probabilities. When she overlaid the predicted interference pattern with the real residual signals recorded by the Deep Space Network, they aligned almost perfectly. She stared at the screen for hours before whispering to herself, "It's not gone, it's just uncertain." The phrase caught on. Among the divide, uncertain object became shorthand for the phenomenon, a symbol of the idea that disappearance could be an act of physics, not magic. Still, uncertainty is a form of erasure. To be unmeasurable is to be, in human terms, invisible. And yet, some began to notice a subtle presence. In long-exposure imagery of the Martian sector, faint speckles of light appeared, not stars, not debris, but stochastic glimmers that refused to stay put. They would flicker into existence for a single frame, then vanish, as though the universe were still deciding what to do with them. Quantum physicists described them as transient coherence events. Philosophers called them remnants of becoming. It raised an impossible question. If the act of looking brings the universe into being, what happens when the universe looks back and chooses to blink? To some, the idea was liberating, a reminder that even the cosmos is not static, but alive in the tension between knowing and unknowing. To others, it was terrifying. For if reality itself can choose to unobserve a thing, then perhaps nothing, not even the stars, is ever permanent. 3I, Atlas, once a speck of dust adrift between suns, had become something else entirely, a mirror held up to existence itself, showing us that the universe is not a stage upon which matter performs, but an actor that can forget its own lines. And in that forgetting, the silence grows deeper, not absence, but the sound of potential. Long before the blackout, the telescopes that watched 3I Atlas had already taught humanity a painful lesson. Discovery does not end with revelation, it begins with patience. Now that patience became the world's only tool, when something refuses to be seen, we build better eyes. So the solar system's most powerful watchers stirred from routine to turn toward the wound behind Mars. The James Webb Space Telescope, parked 1,000,000 miles from Earth, its golden mirrors cold as prayer, was commanded to stare once more at the coordinates where the interstellar traveler had last existed. Nothing returned but a perfection too perfect. Zero deviation in background infrared noise. Yet to the physicists reading those smooth lines, the absence itself became data. If nothing radiated, something must have taken the radiation. Energy had fled or folded. ESA's solar orbiter, spinning near the Sun, was repurposed for side-glance imaging. Its magnetometers sensed minute phase shifts, subtle quivers in solar wind density that rippled exactly every 1.618 minutes, the same golden ratio pulse still haunting the deep space network. Across continents, the word synchronization began appearing in the margins of reports. At NASA's Jet Propulsion Laboratory, the Deep Space Network's engineers constructed a new array of algorithms, pattern hunters, built from machine learning frameworks originally meant for exoplanet detection. Fed with weeks of raw static, the system learned to feel for ghosts, correlations invisible to human intuition. What emerged was not a signal, exactly, but a shape, a recurring dip in broadband noise, rhythmic as breath. The computers gave it a name, Periodic Null Event Type 3. Even Voyager 2, far past Neptune's orbit and older than many of its observers, was enlisted. Its aging instruments strained to detect any gravitational quiver propagating outward from the inner planets. For 3 days in succession, its plasma wave detector hummed faintly above baseline, as if some long, slow tremor were passing through the heliosphere itself. The tremor did not repeat, but neither did it fade entirely. It lingered in the cosmic background, an asymmetry too small to headline, yet too consistent to ignore. Elsewhere, new eyes opened. The Atacama Large Millimeter Array began continuous observation in sub-millimeter wavelengths, searching for thermal echoes, a faint after-image, if 3I Atlas had left even molecules behind. The array recorded nothing except a gentle, periodic distortion in atmospheric water vapor, Earth's own air vibrating in empathy with the silence beyond. For a few tense weeks, the phenomenon seemed global. Atomic clocks in separate observatories showed phase drift on the order of nanoseconds, synchronized with the pulses. It was as if time itself were breathing. Outward, the newest generation of detectors prepared to join the vigil. At CERN, physicists proposed coupling the LHC's data to cosmic ray observatories, hoping to catch stray high-energy particles from the direction of Mars. In Arizona, the Vera Rubin Observatory adjusted its nightly sky map to search for transient arcs of light, possible gravitational echoes of a space-time scar. None appeared. But in their absence lay proof. The sky had been rearranged and then sealed again, flawlessly. The persistence of null results forced a philosophical turn. When every instrument agrees on emptiness, emptiness becomes measurable. The scientists began to chart the contours of the void itself, an atlas of absence. They built three-dimensional simulations of the Mars-adjacent sector, layering electromagnetic data, magnetic flux, particle density, and temporal variance. The resulting model revealed a hollow ellipse, thin as paper, drifting slowly outward along Mars's orbital path. Its interior registered colder than cosmic background, impossibly cold, by about 0.00002 Kelvin. Negative radiation, someone whispered during the presentation. No one laughed. The ellipse expanded imperceptibly each month, a translucent scar migrating through the solar wind. Wherever it passed, instruments recorded fractional energy loss, as though space were exhaling. Webb's mirrors, when realigned toward its path, captured a fleeting photon deficit, a missing brightness at wavelengths that should have been uniform. It was not darkness, it was less light than possible. Across the Atlantic, at ESA's Mission Planning Center, engineers discussed repointing Bepi Colombo's cameras during its upcoming Mars flyby. Officially, the goal was calibration. Privately, they called it a glance into the wound. Meanwhile, NASA prepared for something grander. The Deep Space Observer Initiative, a network linking Webb, the Deep Space Network, the Solar Orbiter, and ground arrays into one synchronized eye. Its purpose: to test whether the pulses were local interference or truly interplanetary. The experiment required absolute precision. Any error in timing could erase the pattern. At 3:14 UTC on a silent Tuesday, the system came online. For the first time, Earth watched the void through every wavelength, simultaneously: radio, infrared, optical, X-ray. For 9 minutes, the sky remained perfectly still. Then, at the 10th minute, a fluctuation appeared. A harmonic resonance swept through all channels, faint but global, curving upward through frequency space like a breath drawn across the universe. The hydrogen line brightened by 1 part in 10 million, a whisper of coherence blooming out of the silence. It lasted exactly 1.618 seconds. The same ratio, the same signature. When the signal faded, nothing else followed. No aftershock, no decay. The instruments cooled in their housings, whispering with thermal noise. But every scientist in the control rooms knew the cosmos had answered their collective gaze. No press release was issued. The data was archived under routine cosmic background variation. But among the insiders, a simple understanding settled in: 3I Atlas, or whatever had replaced it, was still responsive. Not alive, perhaps, but interactive, like a mirror the universe holds up when watched too closely. And so the vigil continued. The watchers became part of the experiment itself, feeding observation into the phenomenon, wondering whether attention might once again make something reappear. Late that night, in the quiet corridors of JPL, one engineer wrote in his notebook, "If it returns, we'll call it 4I. But maybe it won't come back. Maybe it's waiting for us to follow." It began as an itch in the data, the kind that makes analysts distrust their own eyes. In the Deep Space Network's archived recordings of the void, when the hum of background radiation was stripped away and the random static was cleaned, a pattern revealed itself, subtle, metronomic, steady. Every 27 minutes, on the edge of the frequency band where the hydrogen line fades into silence, there came a faint dip, not a burst, not a spike, a drop, a momentary subtraction, as though the universe itself paused to breathe in. At first it seemed coincidence, an artifact of signal averaging, but as the datasets grew, the pattern solidified. The intervals repeated across months, across instruments, across hemispheres. Someone at Goldstone called it the heartbeat of nothing. Teams from JPL, ESA, and the University of Tokyo overlaid the signal intervals with orbital data. What they found was unnerving. The dips aligned precisely with Mars's rotational period. Each time the red planet completed a partial turn, not full day, not sidereal, the silence pulsed like a distant echo of its spin. Coincidence, perhaps, but as the analysts continued, a secondary rhythm appeared, a higher frequency modulation within the larger silence, like a whisper nested inside a pause. When plotted, that sub-pattern formed a Fibonacci spiral, numbers unfurling through emptiness, tracing the mathematics of growth, of shells, of galaxies. The pattern was encoded in absence. The void itself carried order. The analysts did what humans always do with the incomprehensible. They began to anthropomorphize it. They called it the pattern in the silence. And suddenly, the void behind Mars no longer felt like absence. It felt like design. To test whether it was instrumental artifact, NASA synchronized redundant receivers across the globe. The intervals persisted. They even survived hardware replacement, new antennas, new filters, same rhythm. The pattern did not belong to the machines, it belonged to space. Then came a more chilling discovery. When the dips were converted into binary 1 for presence, 0 for absence, the sequence spelled a repetition: 10100010001000001. When transformed using prime intervals, the digits mapped onto harmonic ratios familiar to acousticians, intervals of perfect fifths and octaves, the same proportions used in musical scales since ancient times. Mathematics had begun to sing. Within the deep space network, half-joking whispers spread. The silence has a melody. But others, older and less romantic, felt unease. If this pattern truly came from the region of disappearance, then something or someone was encoding symmetry into the vacuum. Data scientists visualized the signal in time-frequency space, producing an image like a pulse of concentric rings, not random, but recursive. The shape mirrored the very geometry of 3I Atlas's last recorded emission, those faint golden ratio pulses it had radiated before slipping behind Mars. Whatever had happened, the echo still remembered the form of its cause. At Princeton, a small, interdisciplinary team formed: physicists, linguists, cryptographers. Their unofficial mission, to determine whether the pattern carried information. They called it Project Halcyon. Over 6 months, they converted the intervals into multiple encoding schemes: Morse, ASCII, spectral modulation. Each method failed to yield recognizable language, but one, a mathematical transform used in deep learning pattern compression, revealed a curious result. When the signal's internal symmetry was compressed, the resulting data structure resembled an image, a spiral fading into an event horizon, drawn not by human hand, but by ratios inherent to space itself. The image looked eerily familiar. It resembled gravitational simulations of matter falling into a black hole, the same whirlpool curve that Einstein's equations predict when time slows and light bends. The pattern in the silence was drawing spacetime. Word of this leaked, as such things always do. The public caught only fragments, rumors of rhythmic pulses, whispers of messages from Mars. Social networks erupted. NASA issued the usual calm denial. No evidence of artificial signals has been detected. But inside, even the deniers were sleepless, because the data refused to die. The rhythmic dips grew stronger as Mars neared aphelion. The farthest point from the Sunday that shouldn't have mattered radio silence is indifferent to planetary geometry, yet the timing was exact. The signal pulsed faster, as though the rhythm was syncing with the planet's orbital velocity. It was almost as if the void was aware of Mars and was responding. Then, in late April, something changed. For the first time since the event, a measurable photon excess appeared within the void. Webb caught it first, a faint shimmer, 1/10 of a photon per square meter per second, faint enough to be nearly imaginary. Yet, when its spectrum was extracted, it displayed a unique characteristic: hydrogen emission lines slightly inverted. Instead of absorbing light, the space was emitting an anti-symmetric reflection, the spectral signature of stimulated emission, like a laser. The void was lacing. It meant that the vacuum itself had gained coherence, a quantum property shared by particles acting in unison. Coherence, on a cosmic scale, implied information flow. The silence was no longer passive. It was processing. Back at JPL, Dr. Marisol Grant re-ran the orbital models. If the pulses and the photon inversions were part of the same system, the only structure that could link them was a standing wave, a resonant cavity shaped by gravity, light, and motion. The region behind Mars had become a mirror of spacetime itself, a cavity humming with self-sustaining resonance. Somewhere within that mirror, perhaps, the lost object still lingered, not visible, but vibrating. A memory held by the universe, repeating itself in mathematical rhythm. In a late-night memo, Dr. Grant wrote quietly, almost poetically, "Maybe this is what remains when matter forgets its form structure without substance, order without origin, a ghost not of the object, but of the law that created it." The line would later be found scrawled on a whiteboard at the lab, beneath the words, "The silence has shape." And as the world turned, the silence continued, not empty, not absent, but speaking in patterns older than speech, carrying through the thin electromagnetic hush between planets like the low song of an unseen tide. The human mind is a cathedral for pattern. When silence begins to hum, we fill it with meaning. By now, the world's physicists, philosophers, and dreamers stood beneath that new dome of mystery, trying to give language to what 3I Atlas had left behind. They called it the theoretical cathedral, a metaphor, at first a shared construct where ideas could live without fear of ridicule. It began as a virtual forum linking CERN, JPL, Cambridge, and Kyoto, then expanded into a distributed global collaboration, thousands of researchers feeding one enigma, all attempting to build a structure vast enough to contain it. Inside this metaphorical cathedral, hypotheses towered like spires. The first pillar was the wormhole hypothesis. If the object had slipped through space-time rather than around it, perhaps the silence was not absence but tunnel, an open geometry whose other mouth lay somewhere far beyond our reach. Some modeled it as a microscopic throat, born of the object's own exotic matter. Others saw it as a natural resonance point between gravitational wells, a cosmic shortcut that had momentarily stabilized when Mars's orbit aligned with the Sunday. But the math was cruel. Stable wormholes demand negative energy, an impossible fuel, forbidden by classical physics. And yet, the evidence of that faintly colder than vacuum region suggested precisely that: energy density below zero. The wormhole theorists took solace in the paradox. If it exists, wrote one, then the universe already agrees it can. Another spire rose beside it, the cosmic string model. In this vision, 3I Atlas had intersected a filament of ancient spacetime, a remnant from the universe's birth, thinner than an atom, yet denser than a star. Contact with such a filament would shear matter from our dimensions, erasing its electromagnetic footprint while leaving gravitational residue. The periodic pulses, then, were shock waves propagating along that invisible line. It was elegant, terrifying, and beautiful. The vacuum decay hypothesis came next. It proposed that 3 Atlas had been a seed from a different energy state of the vacuum, a bubble of true vacuum, wandering through our false one. When it met Mars's orbit, it briefly touched resonance, triggering a local phase restabilization. The result, a patch of the cosmos that had momentarily reverted to primordial conditions, colder, denser, and incompatible with ordinary matter. Under that theory, the object hadn't just vanished, it had converted, it had become spacetime itself. Then came the information field model. Drawing from quantum information theory, it imagined the universe as a vast computation, each particle a bit in a cosmic algorithm. 3 AATLAS, in this interpretation, was not a comet but a program fragment, an instruction from elsewhere. When hidden from observation, it executed its code. The silence was the reboot sequence of the local fabric, an update written into the operating system of the cosmos. Skeptics laughed, but even they stared a little longer into the static. And finally, above all spires, hung the most unsettling proposition whispered, never published, that 3I Atlas had not been natural at all, that its behavior, the rhythm, the symmetry, the precision of its vanishing bore the fingerprints of engineering. A civilization advanced enough to shape space-time could create probes not of metal but of geometry, encoded in light and curvature. To such beings, crossing galaxies might mean weaving through the fabric itself. If so, then what humanity had seen behind Mars was not an accident, it was a demonstration. The idea drew both awe and quiet horror. For if someone, somewhere, could manipulate the constants of reality so elegantly that disappearance left coherence instead of chaos, then we were not alone, and the universe was no longer a wilderness, but an architecture. The debates grew almost theological. A cosmologist at Oxford compared the event to the burning bush, an encounter not with deity, but with structure itself. At Kyoto, a philosopher of science wrote, "Perhaps we are witnessing the universe debugging its own code." The cathedral filled with such echoes, equations and metaphors intertwined until they became indistinguishable. Meanwhile, data trickled in from every probe still listening. The pattern in the silence persisted, unbroken, slowly drifting outward from Mars along a spiral path. Some said it resembled a magnetic field line, others a gravitational echo. Yet its symmetry remained perfect, too deliberate for turbulence, too stable for decay. NASA's data visualization team rendered the pulses into a three-dimensional hologram. When played at accelerated speed, the void sang harmonic oscillations that rose and fell like breath, converging on a single resonant frequency. That frequency, translated into audible range, produced a tone soft, constant, haunting. They played it once in the control room. No one spoke. The sound felt ancient, like the hum of background creation. Some said it resembled the A-flat tone measured from black holes, those gravitational choirs at the edge of time. Others thought it was the echo of the first moment, the resonance of inflation itself. Whatever it was, it felt alive in a way equations could not explain. And so the cathedral continued to build itself, spire upon spire of conjecture, stone upon stone of mathematics. Yet no theory could close the circle. Every model explained part of the event, but left something untouched, the silence's intentionality. Because every pulse, every curve, every drop of energy seemed to know its place. When asked, Dr. Marisol Grant summarized it best. If this is a natural phenomenon, then nature has learned to write poetry. The rest of the world moved on, missions continued. The public, denied the deeper truth, forgot. But in a few observatories, still awake at 3 a.m., the scientists who had watched the sky blink that night refused to let go. They whispered to each other across continents, using encrypted channels, exchanging new fragments of data, new whispers from the void. The pattern had changed again subtly, beautifully. The intervals now carried a third ratio, the square root of 2, the interval of music's perfect harmony. The silence was composing, and all humanity could do was listen, trembling, reverent, and very small beneath the vaulted geometry of its unseen cathedral. In the end, what science could not interpret, the human soul began to absorb. The equations gave way to questions older than reason. What does it mean when the universe goes quiet? When a thing that crossed the interstellar dark simply stops being measurable, leaving behind only pattern, symmetry, and the sound of its own erasure? The silence behind Mars became a mirror, not of space, but of us. Every generation of astronomers has known a moment like this, a point where knowledge curves back on itself, revealing more about the observer than the observed. Galileo's first moons, Hubble's expanding galaxies, Hawking's evaporating black holes, all of them changed, not the sky, but humanity's reflection in it. 3I Atlas was the next mirror in that chain, but this one looked deeper. It asked whether seeing itself is an act of creation and whether forgetting might be one too. The physicists called it anomalous disappearance. The poets called it the returning. But to those who had watched the feeds blink into darkness, the feeling was neither awe nor fear. It was recognition. For centuries, we have sought permanence in a universe built of change. Stars live, flare, and fade. Galaxies collide. Even light stretches with time. Yet something in us demands continuity, the promise that meaning outlasts observation. The vanishing of 3I Atlas tore at that illusion. It told us, quietly, that perhaps the universe is not a stage for immortality, but a ritual of appearing and disappearing, endlessly repeating its own birth. In that ritual, every discovery becomes confession. After the event, philosophers began writing again long essays, meditations, the kind that no journal would publish, but every scientist secretly read. They spoke of entropy as language, of silence as grammar. One, a cosmologist from Lisbon, wrote, "Perhaps consciousness itself is a form of cosmic feedback, the universe briefly aware of its own symmetry before returning to sleep." Dr. Grant, whose notebooks had filled with equations and sleepless thoughts, began to write in the margins of her data sheets. The lines read like prayers. Light bends, thought follows. What vanishes is only what never truly separated. We name the silence to hear ourselves answer. In this quieter phase of the investigation, the divide between disciplines dissolved. Physicists sat beside theologians, mathematicians beside musicians. The pattern in the silence became a shared meditation. Some translated its ratios into sound, building organs and synthesizers tuned to its rhythm. Others mapped its geometry onto architecture, designing temples of proportion modeled after the void. For the first time in centuries, science had rediscovered wonder without needing explanation. Across the world, telescopes still watched, though most of them knew they would find nothing. Yet that nothing had become a teacher. It reminded us that knowledge is not ownership, that even in an age of high-resolution certainty, mystery remains the universe's native language. In one of her final interviews, before stepping away from public life, Dr. Chowdhury was asked what she thought had really happened behind Mars. She paused a long time before answering. Maybe nothing happened at all. Maybe we just heard the universe exhale, and in that breath realized how fragile our definitions are. The interviewer asked if she meant it metaphorically. She only smiled and said, "In physics, metaphor is just the next equation waiting to be written." As months passed, the pulses faded. The pattern slowed until it became indistinguishable from background noise. The void, once bright with speculation, settled back into its native stillness. Observatories moved on to nearer tasks: exoplanet climates, gravitational waves, the quiet politics of funding cycles. Yet among those who had witnessed the silence, a strange peace lingered. They had seen proof that the cosmos still contained secrets larger than comprehension. For a species born to measure, that realization was both humbling and holy. Because to lose a thing and still feel its echo is to glimpse the scaffolding of reality, the architecture beneath perception, where matter, time, and meaning intertwine. In that place, perhaps, 3i Atlas still drifts, not gone, not elsewhere, but folded into the memory of the very laws that once carried it. And in the dark, beyond Mars, the silence remains not an absence, but a presence too vast for sound. Mars turned slowly toward morning, the red horizon brightened under the cold breath of dawn, sunlight spilling across canyons that had been silent for billions of years. In orbit, the sensors that once watched for 3i Atlas resumed their ordinary tasks, mapping dust, measuring plasma, logging the endless rhythm of solar wind. Everything was normal again, perfectly, almost painfully normal. But the people who had listened to the silence could not forget. Somewhere in the invisible corridor beyond that planet, where geometry itself had twisted and relaxed, the void still pulsed faint, steady, like a heartbeat deep inside spacetime. The Deep Space Network continued to monitor the region in the background of other missions, pretending it was routine telemetry, but always listening, always waiting for the next whisper of structure within the static. Nothing came. Days became months, and the anomaly seemed to dissolve into history, filed among the quiet catalogue of cosmic curiosities, unexplained gamma spikes, transient gravitational echoes, the untraceable radio signals that litter our archives. Humanity's attention drifted, as it always does, toward the next mystery, the next launch, the next frontier. But in the halls of JPL and among the sleepless community of the Divide, the question never faded. Had 3i Atlas really gone, or had we simply lost the ability to perceive it? Dr. Marisol Grant, now retired, visited the Pasadena control room one final time. The place was empty, the lights dim. She stood before the wall of dormant monitors and remembered the moment the screens went black. She thought of the thousands of hours spent searching for meaning in absence and felt an unexpected calm. She whispered to the empty room, "You taught us how to listen." Perhaps that was the true gift, not data, not theory, but humility. For centuries we have believed that progress meant illumination, that every shadow was a question waiting to be banished by light. But in the silence behind Mars, something different had emerged. The understanding that even light has boundaries, and beyond them lies not chaos, but order too deep for human measure. At the European Southern Observatory, a new generation of astronomers looked again toward the coordinates where 3 Atlas had vanished. They did not expect discovery. They sought instead to calibrate the sensitivity of their instruments against the known, using the absence as a standard. The void had become a reference point, the universe's own zero. In its way, 3i Atlas had joined the constellations, not as a visible body, but as a story written across disciplines, a myth of modern science. A reminder that discovery is never possession, that sometimes knowledge must end in reverence. And so, the world continued, the seasons passing, Mars rising and setting in the night sky, the hum of communication satellites threading Earth's ionosphere. Humanity's gaze moved outward again, to Europa's hidden ocean, to Titan's methane lakes, to exoplanets orbiting dim red suns. The search for life resumed, as it must. But always, beneath every conversation about signal and silence, there lingered the same unspoken memory. Once, an object came from beyond the stars, crossed our system, and vanished behind a world of dust and rust-red stone, and in that vanishing, the universe revealed how fragile the act of knowing truly is. Some say that on certain nights, when the deep space antennas turn toward Mars and the atmosphere is still, a faint rhythm can be heard in the static 1.618 seconds, soft, patient, almost kind. Engineers call it background fluctuation, others call it echo, but for those who remember, it is neither. It is the sound of the cosmos breathing. And now, as the last words fade into quiet, the listener drifts with them weightless, unbound. Picture Mars from above, a small red ember glowing beneath the long night of the solar system. The sun's light moves across it, like the hand of time brushing an old scar. Somewhere behind that world, the void turns slowly, indifferent, eternal. The silence there is not threatening. It is gentle, infinite, waiting. Imagine the deep space network's antennas, wide and white beneath the desert stars, their slow rotation a choreography of patience. Each one listens to the hush between photons, to the place where mathematics sleeps. The faint hum of machinery, the pulse of circuits, the breath of wind across metal, all merge into one rhythm, steady and slow. The universe is still speaking, though not always in light. Sometimes it speaks in absence, in the long pause between signals, in the quiet that follows a mystery. It tells us that nothing is ever truly lost. It only changes its form of being seen. So breathe with it. Let the pulse of silence fill the spaces between your thoughts. The stars are ancient, but their language is simple. To appear, to fade, to reappear again in another shape. We are part of that rhythm dust, listening to dust, thought made from starlight. Tonight, 3 Atlas is everywhere. In the hum of background radiation, in the motion of your own heartbeat, in the unseen geometry that holds all things together. The silence beyond Mars is not empty. It is peace. Sleep now beneath it. The universe is watching gently,